Today I'm going to talk about a new form of distributed programming known as web services. Again, I want to remind you that so far we have learned about socket programming, we have learned about remote procedure call, and we have learned about MPI message passing, and all of those under the category of distributed memory. And from the shared memory, which is not the focus of this course, we have talked a little bit about the thread-based. Again, I remind you that the focus of this course is on the distributed memory part, when we have multiple computers, each one with its own memory, and we want to program that, like a cluster. Okay, so now I'm going to talk about a new form known as web services. I do like to talk about MapReduce as well. However, because of the circumstances in this semester, I have to skip that. Okay, so let's first see what is a web service. And you guys have probably heard of it. Uh, However, there is a common mistake or misunderstanding of this word. First of all, I want to clarify what we mean by web service. So you know the web. If you know internet, web is the main pillar of that. So most of the thing, if not everything nowadays within the internet happens through web. Web is the technology within internet that facilitates communication between the user and the server. Okay, now this can be called a web service, like the service that we get via web, right? For example, when you check news on CNN or any website, you are using the web service. Okay, so this is the common meaning of web service. However, in this course, or more technically, more technical side of it, web service has a slightly different meaning. So web service is in fact a technique using which we call another function on another computer or on a server. In fact, it's a technique to stitch together multiple applications. Why it is called the web service, or what is the word web here? Because that stitching between multiple applications happen via HTTP protocol. So HTTP protocol, which is Hypertext Transfer Protocol, is the backbone of web. So you can imagine that web is a commercial name and HTTP is the protocol behind that. So now we use this protocol not just to open a web page that we do all the times, but this time we want to facilitate that communication, that existing, highly available, highly used service or protocol known as HTTP, not for opening websites, but for programming, as a facility, as a channel between two applications. So application A and application B can communicate via HTTP. All right, so this fashion of communication is particularly good for applications for pieces of application that are far away from each other, not on a single server, not within one organization. Generally, it doesn't have to be, but generally it is across organizations. Well, when it comes to across organizations, we know that each organization have their own restrictions. So they may not have all the ports open, but often, if not all the times, the web port, the HTTP port, is open. Therefore, this makes HTTP an ideal vehicle to enable communication between two applications on two different organizations. All right, let me give you a better example, a good example of web services. Let's think that you are purchasing something from Amazon website, right? So you go to the Amazon website, you search for an item, You find the item that you want, and then you move on in the purchase process. You enter your destination address, and then you have to manage payment. You have to do the payment. You know that Amazon does not do the payment. Payment is done by other financial companies or banks. So this is a different entity that manages the transaction, the payment. So in this case, what happens is that we or Amazon has to call once you enter your card information and all that, and press payment or press pay. Then that information has to travel to that bank server. In there is an application waiting for or listening to the line, and then gets those data, and then does the transaction and sends the acknowledgement or the failure. So this is a perfect example of where web services are critical. So web services are good for these circumstances. I would like to remind you that other distributed programming techniques that we introduced have their own applications. For example, MPI, message passing interface, that was the first thing that we discussed in this category, is mainly for developing parallel HPC applications, doing high-end simulations of scientific things. That is not for this type of bank transactions or things with this nature. Alternatively, we had RPC RMI, which had its own application. It's more similar to web services, but that is generally used within one organization, within one distributed system, for close connections between different pieces of a program. Whereas web services are generally used for still different pieces of a program that are owned by different organizations and are generally available internet-wide as opposed to within one organization. So these techniques that we teach here, they have different applications. All right, nowadays, most of standard applications, internet-based applications, in addition to their normal interface, they do provide a set of APIs. APIs is the acronym for Application Programming Interface. So basically, in addition to let's say Dropbox or Google Drive or any other like Flickr, whatever applications, most of these popular applications, in addition to use them within a web context using your browser, you can programmatically call their services. Let's assume that you are building an application like Uber application or Lyft or whatever. And within that, you need a map service, right? One way is to develop the map service by your own within your application, basically having it built in. Or alternatively, you can get it as a service from a provider like Google. So for example, Google Map, in addition to that nice interface, it exposes some APIs that you can call and basically bring that map service within your application. And you have seen that in many instances. For example, you may go to your bank website, and then in there they have locations of their banks, of their branches, and then when you go there, there is a map. So that's a kind of what I'm talking about. All right, so this is the notion of web services, or that is done via web services. This is mostly the notion of APIs. So they expose different APIs. For example, in Dropbox, we have an API, or Google Drive similarly. We have an API to upload a file, or download a file, or delete a file, or view a file. Different APIs are available. All right, so this is the concept of APIs. And the APIs are the key for web services, because what web services achieve is basically enabling calling these APIs remotely via HTTP protocol. All right, so with that introduction, let me see if what we have in this slide and if I talk about all the things. So application programming interface, a set of methods exposed to other programmers or processors. Programmers can call other methods, which is called services. So services in this case is pretty much the notion of method that is callable remotely or from outside of the program, without knowing their implementation details. So this is the good thing. So for example, when you use the map API, then you don't need to develop maps by yourself. You don't need to know the details of the mapping service. You just call it. You just pass a function with some argument, and you get the result. Okay, so it enables abstract programming, and you just mash up different services and build a new service. And by the way, that's one of the most commonly used way of building softwares nowadays. You probably have heard of things like DevOps and microservices. They are all based on this web services and API technology. All right, so there are several examples of APIs, for example, in Visa cards or any kind of financial institution, Dropbox, and many other examples. All right, so the word API, however, is more common. So you can say Java API. This is not necessarily talking about web services. It means that there are some functions that can be called without knowing the internal knowledge, without having the internal details or knowing the internal details of that functions. All right, so here is a snapshot of APIs of one application. I guess it's a Flickr. So, for example, you can see things like how to upload a photo or different formats, requesting different formats, and different functionalities are the APIs of Flickr. All right, so if we make an API and make it available via HTTP, then we have a web service. All right, so it uses an HTTP-based protocol, so that I already talked about. Within HTTP, so we have a little bit of HTTP. We need a little bit of HTTP knowledge to understand what we are talking about. So HTTP has multiple commands within it. So HTTP is a protocol. It supports multiple commands within that protocol. Four most popular commands of HTTP are get, post, put, and delete. I will elaborate on them in the next slide. And I talked about the fact that this is good for large-scale distributed applications where different pieces of a software is coming from a different organization. And then, of course, here is an example of a set of APIs provided by Flickr. Okay, so web services, so far we have two versions of web services. One is SOAP, which is the older one, Simple Object Access Protocol. That is a pretty old version of web services. The more recent and extremely highly used version of it is known as REST APIs, RESTful APIs, meaning the representational state transfer. So what does that mean, representational state transfer? I guess the state transfer is easier part to explain. So basically, and as I explained in a few slides earlier, what we try to achieve here is calling an object via HTTP protocol, calling a function. And functions generally nowadays coming under classes and variables within that class, and they generally have a state. right? So for example, if you want to fetch the information of a given book, so you want the name of the book, you know, the author of the book, the edition of it, and some information about that. So those are called the state information. So the state of that book object. So we want to transfer the state of the object. And then it has to be representational. So basically in web, we have different representations of those state data that are being transferred. It might be plain text, which is not very common, but it is possible. But it can also be formatted in a more machine readable form, like for example XML. So you can transfer data in XML format. Or another version, another method is called JSON. It might be transferred, it might be represented via JSON format. So these are technically do not have major differences. Some people are more pro XML, some people are more pro JSON. So there is no fundamental differences between them. So basically, we can understand that REST APIs provide us the ability to fetch the state of objects or manipulate or fetch the state of the objects in a format, within a format that can be a plain text or XML or JSON and whatnot. Okay, so so what does it deliver when we say representational? It represents what? I said an object, but in a more HTTP terminology, it's called a resource. Okay, so what is a resource? A resource in the internet / HTTP terminology is anything that can be named and stored in the internet, right? So, for example, when you write a comment for your friend's post in Facebook, that comment is a resource. That post itself is a resource, specifically because you can get its URL and share it with others. A web page is a resource. An image within that web page is a resource. Almost everything is a resource in web, in HTTP, and more specifically speaking, whatever that has an address is a resource. Okay, like a picture, like a web page, a comment, and things like that. So whatever you can do an operation upon is a service, is a resource. I'm sorry. Okay, and then we have the word URL that you are familiar with, but now it has a more meaning for you. URL is the acronym for Universal Resource Locator. So basically, it locates resources for us. Okay, so for example, when you say some address of a picture within a web page, so this last part specifically is the resource. The whole thing is the URL, which is the address of a machine and the protocol to access that, and the address of the resource within that machine. In this case, image 1. All right, let's talk a little bit more about HTTP protocol. As I said, HTTP protocol has multiple commands within it. There are 4 commands that are more popular than others. First and foremost is get. Get is the HTTP command that we use it all the time. Whenever you fetch a website, you use get. When you do get, you are asking the web server to send you something. You want to get something from the server. All right, so that can be a picture, that can be a web page, or any information that you request. It can also be reading the information of a book that you are requesting via web services. Okay, so this is a get request. Basically, it's like a read command from the server. Then we have put put command. Put is the opposite of get. You can imagine it writes something on the server. For example, when you upload a picture, that's a put command. So, and then when you upload a new picture replacing the old one, again that's a put command. So put is basically either creating or updating a new resource or a resource. Put is known to be idempotent. What does it mean? It means that if you do it multiple times, the last write would be saved. Let's say if you change your profile picture in Facebook, let's say you do it 10 times, or your internet connection has some problem and you don't know if it is done, or you do it again, doesn't matter. The last one will remain. All right, so that's called idempotent. So put is the basic thing that you should know is that it is a write operation. Okay, on the server side, it's writing a resource, and it is idempotent, which means that if you do it multiple times, the last one will remain. Okay, delete. I guess you are familiar with. So when you delete an object from the server, you are in fact issuing a delete command of HTTP. Let's say when you delete a comment from the server from a post, or you delete your post from Facebook, that's a delete operation. And finally, we have post. Post and put are very similar, almost the same thing. However, the only difference is that post is non-idempotent, which means that if you do it multiple times, if you write multiple times, it creates multiple versions of it. For example, I guess you have experienced that, for example, when you write a comment in Facebook and you don't know if it got submitted or not, and then you do it again, then you will end up having two similar comments. That is because a post has been used behind the scene. So the only difference with put is that it does not replace the last version will not be the one that is committed, but for whatever number of times you post something, that number of objects or resources are created on the server side. All right. Okay, now we are familiar with HTTP and we are familiar with web services or APIs. Now we want to know how to convert an API, a function, a method within a class, or a resource, how to make it available via HTTP, or what is more technically called as a REST API. Our default programming language here is Java. These facilities are available in most of current languages such as Python and others, but our default language here is Java. All right, so because everything is being handled via HTTP and web, so you can imagine that we have to have a web server. And the web server that is used for Java basically can interpret Java code is Apache Tomcat. So you have to install that. And of course, Java must be installed. That's a no-brainer. So there are several tools that facilitate creating web services in Java. The one that we use, and the easiest one, the most straightforward one, is known as GRPC. So it's a library. It's a bunch of jar files that you have to add to your project to be able to develop web services. All right. So you have to import it to your project. All right. So then the next question you may ask is that, all right, so now I have all the tools. I know what is API. I know the HTTP commands. I have Apache Tomcat and I have GRPC. Now, how to develop an API or a web service? The way Java facilitates web services is using annotations. So we do not have any direct instruction in Java for web services. Instead, we have annotations. That is done via annotations, as we can see in the next slide. Okay, let's write a hello world application in web service form. Or basically, let's create a hello world web service. Okay, so the class that has the functions, that its functions are exposed via HTTP, is the resource. So we have to give it a path, similar to the path that you give to a picture within your computer, like that /www/pictures/image1.jpg. So the same way, there is an annotation called add path, and then within that you give your class a name, or your resource a name. Here I gave it the name /hello. So the path annotation determines the location of this class with respect to the object, to the project URL. So, and then there are some imports that you need to do that is generally taken care by the IDE that you use, for example, Eclipse. Okay, so then it comes to the functions that you want to expose via web services. So you should determine a specific method is answering which type of request. So if you want to return something to the user, if you want to do a read operation, you have to use the get annotation, @get. And then you have to identify, you have to declare what type of data are being, or what type of representation, better to say, is being returned. For example, in this case, I want to return the output of this method in form of XML. So I would say media type dot text XML. All right, and then we have our function, and the rest of it from this point onwards is just Java, right? So you just use, if you ignore the top part, the top two lines, basically these lines, the rest of it is just Java. It's just a function that returns a string value. In this case is null, but you can give it any value you want. Okay, so here instead of XML, you can use other formats as well. You can do a JSON or plain text as well. So here we have the extended version of it, that it has multiple functions, but they all do the same thing, but they just return different formats. So this returns HTML, this returns JSON, and the first one returns XML format. And you can see that in each case, we just format the resource, format the string that we are going to return accordingly. So here, for example, we formatted an XML. Here for JSON, I have not written it, but we can do it. And similarly for HTML. So this is also possible. All right. Now, once you are done with the with creating the web services, now it's the time to consume that. All right. To consume a web service, you can do it via browser. So basically, you can open a browser and you go to the address of that object that you want to invoke, and then you do a call. Basically, you hit enter and you do a call to that method, to that web service, basically. However, or more importantly even, you can develop a program, a client side, that invokes functions of the server side, right? For example, you imagine you are developing the Amazon website and you are calling the payment system of Visa card or MasterCard or other financial institutions that are supported. So this is the type of scenario that we are looking at. So in this case, the transaction is initiated via code, not via the URL directly within the browser. So what I'm trying to emphasize is that you can you can call a web service via browser, not very common, and you can call it via by developing client-side code. This is more common. And there's a third option as well. The third option is some tools, because the client side is generally not as important as the server side. The server side or the part that the API is being exposed is where the logic is, and it's more important. So sometimes, or most of the times, we want just a tool to test if the web server, if the web service works fine. So in these circumstances, what we do, we can use some ready-made tools. For example, there is a tool called Postman in Google Chrome. That's an extension to Google Chrome that you can install on your Chrome, and then it enables you to call web services without developing client-side code. But you can also develop your own code that gives you a better vision of what is happening. All right. So if you want to develop client-side applications, again, you need GRPC libraries. But the client side is definitely simpler than the server side. Okay, it includes 3 steps. First, you have to create a client object. So you can use client builder, which is part of the GRPC, and then create a client object. Then you can define a target for that. This is pretty much connecting that to that resource. So here you give the address of that resource, that object you want to get access to. You can use the target class, web target class, and then using the client object that you made, you can connect it to a certain target, which means the class that you built, that you want to connect to, and then do the basically call the function. So using this target object that you build, you can do a request, and then you can ask the type of output that you expect to receive. For example, here I say that I want the XML version to be returned. And then you do a get. This get is that HTTP get command. You say that I want to read some object from the server side. And then it automatically goes to where the get, let's say this one. You don't need to call the function directly. You just get the call the get, and based on the format of the output, it calls the appropriate function. And then you pass a string, because here you expect a string to be returned. All right, so this was the web service part. I want to talk about one more recent technology known as GRPC, so which is Google Remote Procedure Call. This is not web services. This is more recent than that. I would think it's not more than 2-3 years old, but it is very attractive, and many developers are shifting to GRPC. So it's a Google open source product, and it is, to my understanding, it is something between RPC, RMI, and web services. So it has the advantage of web services in being programming language independent. And by the way, note that web services are programming language independent, which means that your client side or the web service might be developed, let's say in say Python, and your client-side code might be done in Java. So it doesn't matter. So they can talk to each other. So it's like sockets. It's programming language independent. But it is more for far-away communication. So gRPC has that ability to be language independent. However, it is like gRPC in the way that it enables the communication within pieces of a program in a short distance. Basically, how to connect, how to pipe microservices within a bigger application is done by a gRPC. It's not very straightforward. You need to develop something called as protofile when you define the function formats, like interface, if you will, in Java, and then you have to implement those interfaces. I just wanted to introduce you this concept. This is not part of our course, but I just want you to make aware of this technology. All right, with that, we can wrap up this chapter. In this chapter, we introduced different programming models for distributed systems. We specifically talked about distributed memory and a little bit of shared memory techniques. This is very important. Please be aware of it. On the shared memory, we discussed thread and OpenMP, mainly thread. And then on the distributed memory, we talked about sockets, MPI, RMI, and web services. I did like to cover web services as well, but we did not have time in this current semester. Thank you and have a good day.